Hi there, you are watching a video of shell and tube heat exchangers for industrial plants. The contents that will be covered in this module have been outlined to understand the design process of this element in order to arrive to an adequate design. In general, heat exchangers are used to exchange energy between two fluid streams in a particular process plant. Common examples are radiators, water heaters, evaporators, steam generators, etc. A first classification of heat exchangers could be made according to the construction type in tubular, where shell and tube heat exchangers fall, plate and frame, high transfer surface in a condensed footprint, and extended surface, large heat transfer capabilities, such as air coolers and cooling towers. Air coolers are a type of extended surface heat exchangers. The main objective of this type of equipment is to cool large amounts of fluid, mainly in liquid state. As seen in the animation, the hot fluid enters through the right head, indicated with arrows in red, while the cooling fluid, which is air, is driven by motors and goes through the tubes. Another type of heat exchanger is the plate and frames. This type of equipment can interchange small amounts of heat in comparison with air coolers. These are normally used for clean fluids, and the space that they require for the installation is very small. As seen in the animation, the hot fluid rises through the plates, indicated in red, while the cool fluid moves in the opposite direction, thus producing the heat exchange. One type of tubular exchangers are the hairpin type. Also considered within the shell and tube heat exchangers classification, this equipment is for reduced installation spaces. This type of equipment can be manufactured to satisfy a wide range of pressures and temperatures. Obviously, as seen in the picture, it also can be fabricated in very different sizes. The main reason that led to the development of these design codes was essentially to relate shell and tube heat exchanger manufacturers in order to unify the design criteria and produce better final quality equipment. In other words, safer exchangers. It can be said that there are two groups of design codes: mechanical design codes and pressure design codes. Since a heat exchanger is also a pressure vessel, each mechanical design code relates with a pressure vessel code. The pressure vessel's codes to be used is defined in the scope of each mechanical design code. The most widely used codes for the mechanical design are the TEMA code, largely used in petrochemical refineries and applications in general, and the HEI standard, mainly used for power plants. Both codes prescribe the use of the ASME Section VIII code for the design pressure. The TEMA code, developed by the Tubular Exchangers Manufacturers Association, aims to regulate the criteria for the design and manufacture of shell and tube heat exchangers for general applications. The scope and applications range is stated in the TEMA code, which should be consulted prior to any design. The objective of these restrictions is to regulate the stress induced in the materials. As previously stated, shell and tube heat exchangers can adopt many different configurations. All possible combinations are indicated in the TEMA classification chart included in the code. As an example, an AEM type shell and tube heat exchanger will consist of a stationary head type A, a shell type E, and a rear head type M. This standard by the Heat Exchange Institute was developed to establish minimum requirements of design, manufacture, testing, and operation of shell and tube heat exchangers for power generation plants. Same as with the TEMA code, the scope and restrictions of the HEI standard shall be consulted prior any design. HEI classification follows the same pattern as the TEMA code. In this case, the equipment is divided into 5 columns instead of 3, and the final exchanger designation combines both letters and numbers. As previously mentioned, both TEMA and HEI prescribe the use of the ASME Section VIII code for the pressure design. The ASME Boiler and Pressure Vessels Code is a set of standards, specifications, and design rules based on many years of experience, all applied to the design, fabrication, installation, inspection, and certification of pressure vessels. Some of them are construction codes, such as sections 1, 3, 4, 8, 10, and 12. Some others reference codes, such as sections 2, 5, and 9. And some others rules for operating, inspection, and in-service maintenance, such as sections 6 and 7. It has 3 main subsections. Subsection A, General Requirements, where the most used part within this section is Part UG, General Requirements for all construction methods and all materials. Then we have Subsection B, Fabrication Requirements. In this case, the most used part within this section is Part UW, Requirement for pressure vessels manufactured by welding. Then there is Subsection C, Material Requirement, where the most used part within this section is Part UCS, Requirement for pressure vessels constructed out of carbon steel and low alloy steel. And finally, we have the appendices, mandatory and non-mandatory.